Images, audio files, PDFs, even data coming from the internet. Python doesn't store any of these as text. So, how does Python understand them? Today, we are going to uncover the final data type in Python, the one that deals with the real world raw data. Hello, learners, welcome to your learning hub, the Learning Loop. I am Swati Sharma, and this is the 17th video of my beginner friendly Python course series. If you are joining me for the first time, thank you for dropping by. And please do not forget to hit subscribe and press the bell icon so that you do not miss out on any future videos. And if you are just beginning your Python journey, I will highly recommend you to go back and check the previous videos out so that you are all caught up. Today we are going to uncover the final data type in Python, binary data types. So, without a further ado, let's dive in. Let's quickly understand what are binary data types. When we work normally with Python, we use text or strings, numbers, lists, etc. But computer itself doesn't understand these text or images or videos, it understands bytes. A byte is just a number between 0 and 255. Now, binary data types helps Python store and work with these bytes directly. This is important when you are dealing with images, audio or videos, PDFs or zip files, network data, or anything that isn't a simple text. Python gives us three binary data types: bytes, Bytearray, and MemoryView. Let's quickly understand each one with simple examples. Now let's understand the very first binary data type, bytes. Bytes represent an immutable sequence of numbers between 0 and 255, which means once the bytes object is created, it cannot be changed. Now you might be wondering, why do we need bytes? We need bytes because we deal with a lot of real world data like images, audio files, PDFs, and even the data that you get through the internet, which is stored in the raw byte format. And now Python needs a way to hold that raw byte information without changing it. And that's where bytes come in. You can think of a byte as a container that Python uses to store fixed, unchangeable binary information. This might feel really heavy and you might not be a lot of things might not be making sense, but as we progress through our Python lessons and we start dealing with some real world data, it will start making sense. So for now, let's keep it high level. Let's understand that there is a binary data type and to which we have three types, and let's just try and understand it, because once we start looking at more examples, we go through more Python lessons, it would start making sense. Now let's quickly see how we can create or declare bytes. Right, let's quickly see how we can declare bytes. I will be giving the variable data to declare a bytes, and I will be giving a prefix b to tell Python that anything in the code should be stored as a binary information. So let's say I do hello, and let's all print this data and then also try and see the data type for this particular variable. Let me just write data type, comma, I'll give this, data is equal to this. Okay, let's run this, and you can see the B in front of hello, which means it is being stored as a binary information. And you can also see the data type is bytes. There's another way to declare bytes is using the bytes keyword. So in this case, I'll be giving the variable data underscore one and then the bytes keyword, round brackets, and now I will give any string that I want to declare. And then along with that, I also have to give the encoding. Okay. Yes, I'll give UTF-18, sorry, UTF-8, and then I'll just print it and you can see this has been printed. You can also give any iterable item, that is list, tuple, sets, frozen sets, to declare under bytes as well. So let's say data underscore 2 is equal to, and I say bytes, and then I can give any iterable item and I can declare the numbers and make sure the numbers are between 0 and 255. So let's say 245. I run it. Okay, I need to get the output as well. So I'll do data underscore 2, run it, and you can see a binary information for the same. Let's try and give anything outside 255 and see what really happens, because we shouldn't be giving that when we are giving any iterable. Let's say I give 256, 67, 23, and data underscore 3, and you will see the error that we are getting. That's here. Because the numbers in this iterable item or the numbers within the list, tuple, or set should be between 0 and 255. Please do remember that. Now that we understand bytes, let's look into the second binary data type, byte array. Byte array is very much similar to bytes. It also stores the numbers between 0 and 255. The only difference is that byte array is mutable, which means once the byte array object is created, you can change its values. It is helpful in situation where the binary data needs to be modified, adjusted, or maybe processed step by step. For example, you might want to change some part of the data that you received from device or tweak some values before sending them somewhere else. We are not working with these scenarios yet, but once we reach topics like networking, image processing, or advanced file handling, you will see why modifying raw data can be very useful. Now let's quickly see how we can create byte array. Let's see how we can declare or create byte array now. So let's say I create a variable data underscore changeable is equal to byte array and say b, that stands for bytes. Hello. So what I did here, I have changed the bytes to byte array. So in the brackets, I am telling Python to read whatever in the codes as a binary data and create that as a bytes. That shouldn't be changed. And then I'm changing that to byte array so that data can be changed. So, and now I can check the data changeable data and you can see it has been created as a byte array. Or you can also directly give the variable where you have saved the bytes data. I'll give byte array and the round brackets, and then I'll give this bytes variable that's data, and that would also be converted to byte array. Run it and you can see it has been created to byte array. You can also use the byte array constructor directly to create a data, something like this. Give the iterable within the byte array constructor and you can see the byte array has been created. You can change the values more or less the same way you were able to change it for any other sequence data type. You just need to give, for example, I want to change anything at the 0 index and I'll say 56, and let's now check this data. You can see this byte array output has been changed, which means once I did byte changeable to square brackets 0, that's the index number because it's at 0, 1, 2, and it will change whatever we had at the 0th index. Now let's talk about the third and the final binary data type, memory view. To understand memory view, let's compare it with Bytearray. So when you use Bytearray in Python, it creates a copy of the binary data in the local memory so that you can edit it. And every time we edit it, it will be edited at the source, no issues. But whenever you try to access some part of the data, so how would we access some part of the data? That would be using slicing. So every time I try to access some part of the data using slicing, I have to create a new object so that I can view some part of that data, and that would create a new variable or new object, and that would use more memory. Now that's fine if I am using a small data set. But if I'm using a large data set with like 10,000 rows or columns, or big files or images or heavy or longer audio files, that could be a problem because it will use a lot more memory if I'm trying to access the parts of the data every time, and we might encounter the performance issues. Now that's where the memory view comes in. So if you're dealing with large data sets and you want to access some part of the data, it will not create the copy of the data. So what it would do is it would let us see the data or view the data without creating an extra copy in the local memory. So that's the use of memory view. So if you are using or dealing with large data set, memory view can help us view or access those parts of the data without creating that copy of the data in the local memory, and which results in less memory usage and faster performance. Now let's see how we can declare or create a memory view. Now the memory view cannot hold the data itself, so it should be created from another binary object like bytes or Bytearray. Let's say I create a variable mv and I'll write memory view, and we know that previously we created data as bytes, so I can create a memory view to my binary data type, and you can see it's just pointing at the location. It says memory at, and it has not created any copy or anything. It's just pointing to that data, and you can just start viewing this data. For now, as we are creating a memory view on bytes which is immutable, remember you cannot change or edit anything using the memory view. Yes, you can also edit or change the data using memory view only if the underlying the binary data or binary object is mutable or is Bytearray. Otherwise, we are just getting a read-only access to that particular memory or object. Same ways, you can create the memory view to your Bytearray data type. So I think that's data changeable. That's what it is. Let's see. Yep. So let's say here memory view data underscore changeable, and then use mv underscore 1, and you can see again it is pointing at the memory. Right? It has not created any extra copy, not used anything. It's just created a window to view that data. Now you can view some part of the data as well. You can use the slicing. Let's say I say part view, and I'll say mv, and then underscore 1, say 0 slash let's say 3, and let's try and view this as well. And you can see again it is pointing at that. And let's see what happens if we say print. Now we are getting only this memory at something, and we are not actually seeing the data. So you might have a question how we can actually view the data. So you can just do here part view and then dot, and then we will write to bytes. it will give whatever we have at that. You can see it, the binary view of that, whatever we have stored. You can see data changeable is hello and 0, 1, 2, because 3 shouldn't be included, so it should be HEL, and that's exactly what it gives. So you can use 2 bytes to actually view the data. You can also use something called as toList, which would give us the sequence of numbers between 0 and 255, but not the actual value. See, and you can see it gives 72, 101, 108. That stands for hello, that's for H, that's for E, that's for L. So you can use that as well, but mostly you'll be using 2 bytes or toList. These are the only 2 main functions that you will use with MemoryView to view actual data. And again, there's no copy created, no extra memory is being used. You just save the memory while you also was able to see the data. Now, as we have this part view on my byte array data, which means it can be changeable, it's mutable, I can change that as well. Let's say I want to change this MB1 data and I want to change the capital H to small h. And let's see how we can do that. So we can write MB underscore, MB underscore 1, square brackets, and I'll write the index number, which is 0, is equal to, and then I'll write odd, and then I will write H. Now I have written odd because that's the underlying data is the binary data. So I need to use the function odd if I want to edit the string. So now let's see MV underscore 1, run it. Let's do 2 bytes to see if it has been changed. You can see it has been changed, and because I told you that it would also change at the source location. So let's see the data underscore changeable, if that has been changed or not. And you can see that also has been changed from capital H to small h. We will use the same way to change the data on my byte array as well. Like say if data changeable and I say 0, and let's say I want to change it back to capital H, so I'll do odd and then I'll say H, and let's just try and get the output for the same. You can see it has been changed, and let's see if my memory view has changed. And you can see that also has been changed. With this, we have come to an end of this video, and we have completed the binary data types in Python, and also with that we have completed the data types in Python. From the very next video, we will start the new topic, that's operators in Python, and we will cover the assignment and the comparison operators in the very next video. That's it for today, guys. If you like my content, please like, share and subscribe. I'll see you guys in the next video. Until then, happy coding.